All right, hello geometry students. This is Mrs. Spencer here. We're going to talk today a little bit about isosceles and equilateral triangles. So I'm going to title my paper here. Okay, so this is something that I hope you're familiar with, and last class you looked through this a little bit, going back over the definitions. We've got isosceles triangles, which have two sides congruent, and equilateral triangles that have all three sides congruent. And from these definitions, we get a lot of really nice properties about these triangles, and we can prove all sorts of other things about them. First thing we need before we really dive into isosceles and equilateral triangles is we need something called the third angle theorem. In a few classes back, you learned that all three angles in a triangle add up to 180 degrees, which is really, really good and very, very helpful, and we've solved lots of problems with that. What we also have, though, is if I have two triangles, let's say here's a triangle, and I've got this other triangle over here. Let's pretend like I'm good at drawing and that those are about the same size. If I know that these two angles are the same, and I know that these two angles are the same, we can also imply that these angles are going to be the same as each other. If we think about this with numbers, this is an obtuse angle. We call this maybe something like 130 degrees. We say those are the same. And then we have these that are the same, maybe, I don't know, 35 degrees. Then we would solve the exact same equation to figure out that these are also the same. So we have 130 plus 35 is 165. Take that away from 180 degrees, and then these angles would be the same. So that is what the third angle theorem states. If two angles in one triangle are congruent to two angles in another, then the third angles are also congruent. And that is very useful in our much dreaded proofs later on. We'll use this third angle theorem to help us with proving that triangles are congruent. All right, let's dive into some of today's stuff. So isosceles and equilateral triangles. So if I have an isosceles triangle, we've got two sides congruent, and we've got tons of other stuff that we also know about these triangles. So I'm going to take a piece of paper. You don't need to do this part. We'll work through it here in a second. Take this piece of paper, I'm going to fold it, and I'm going to cut a triangle from this. Let's see. Something like that. Okay. So I kind of folded it, and I cut a triangle. I wanted to cut this triangle so that this side lines up with the side that's underneath of it, okay? This is going to make an isosceles triangle because those sides lined up. So this side and this side are the same because when I had it folded, they're right on top of each other. So those sides are congruent. Additionally, so we know it's isosceles because we've got two sides congruent. Additionally, we know that this angle and this angle have to be the same. So if I had my triangle folded, they're directly on top of each other. They line up. So these angles are going to be congruent. This is what we call the base angles theorem. If you have an isosceles triangle, then we know that base angles have to be congruent. So let's summarize that. So base angles theorem. If two sides of a triangle are congruent, then the angles opposite them, or the base angles, are congruent. So if I draw a nice little picture here, an isosceles triangle, if you know those sides are congruent, then you know these angles are congruent. And actually the converse ends up being true. So the converse meaning if we know the base angles are congruent, then we know that we have an isosceles triangle. So we've got base angles converse, which you learned about converses ways back, and that just means that we're going to flip our hypothesis and our conclusion. So the converse of a if-then statement is just a flip of the hypothesis and conclusion. So we have that if two angles are congruent, in a triangle, then opposite sides are congruent. So that is our base angles theorem. Very, very, very useful theorem. All right, last thing we've got, and this is something that I'm almost certain you've learned about before, is equilateral triangles. So if I have an equilateral triangle, meaning all three sides are congruent. Ooh, that one is not great. Start over. That's better. So if I have a triangle where all three sides are congruent, I also know that all three angles will be congruent. So if you have an equilateral triangle, then it's also what we call equiangular. And if you have an equiangular triangle, then it's also equilateral. So if all sides are congruent, all angles are congruent. If all angles are congruent, all sides are congruent. The question is how big would one of these angles be? Well, the three angles in a triangle add to 180 degrees. We want to break it into three equal parts. This was actually, I think, on a test a while back. So each angle would be 60 degrees. So in an equilateral triangle, all angles are congruent, or 60 degrees. All right, thanks for Thanks for watching. I hope I kept this short enough and that you learned something so that you can get to work on your homework. Thanks for watching and have a great rest of your day.